Welcome to this session. Today we have to discuss about the chemical properties of ozone. It is very important one which is asked for your IP level. Okay. So apart from that, the first chemical property is when ethylene is participate in the reaction in presence of the O3 in presence of the O3 to form as a intermediate structure. This is a intermediate structure. Okay, so that is called about the intermediate structure is named as what? Ethylene ozonide. Ethylene ozonide. Again, it is participate in the reaction by using zinc as well as water molecule to formed as the formaldehyde. That means what? The ethylene is converting here formaldehyde by using ozone as well as zinc. So this is about the first chemical property of the ozone. Then second chemical property, that is when acetylene is react with ozone, then to form intermediate structure. That intermediate structure so called as acetylene ozonide. Ozonide means this structure, this type of structure is called as what? Ozonide. That's why it is a acetylene ozonide. Okay. So again, the acetylene ozonide intermediate is participate in the reaction by using zinc in presence of water molecule by using water molecule to formed as the glycol. This is called a what? Glycol. That is glyoxal. Okay, glyoxal. Right. So then second one, that is third one, when but2 is participate in the reaction by using ozone to formed as the again intermediate structure, that is but2 ozonide, then which is also participate in the reaction by using zinc oblique water molecule to formed as butane 2,3 dione. Butane 2,3 dione. So this is about the important ozone chemical reaction which are more useful for your IPE level. That's why students, dear students, you have to more concentrate on this type of reaction. Okay, then here some more chemical reaction during the ozone. When PBS when PBS is reacted with the ozone, then it is converting as the forming as the PbSO4 as well as oxygen. That means what? Lead sulfide is reacted with ozone membrane, that is ozone, to formed as lead sulfate plus oxygen. And next one here. Here, next one. When sulfur is reacted with the ozone in presence of the water molecule, gives rise to form H2SO4, that is sulfuric acid as well as oxygen as a byproduct. So this is about the chemical reactions of ozone, right? So then it is very important one. The maximum question paper is containing this type of question, so it will carry 2 marks in your IPE level. Okay, dear students, what is that? Tailing of mercury. Tailing of mercury, very important one, right? Here, as ozone passes through mercury, it loses the meniscus and sticks to the glass because of mercury formation. That is process is called tailing of mercury. Very simple. When we will pass the ozone through mercury, hello, something voice is there, right? We discuss about the tailing of the mercury. When we will pass the ozone into the mercury containing container, then the mercury is loses their meniscus. Loses their meniscus. What is the meaning of meniscus? To loses the focus of the lens. To loses the focus of the lens. That is called meniscus. Why it is loses the meniscus means there is a formation of the mercuric oxide. So that process is called tailing of mercury. Already I've written here the tailing of mercury. Here when mercury is reacted with ozone, is gives rise to form Hg2O as well as O2. So this process is called tailing of mercury. Simply we have to conclude what is the meaning of tailing of mercury. That means what? By passing ozone into mercury, then the mercury is loses their meniscus and it will stick to the walls of the glass. That process is called tailing of mercury by formation of Hg2O. Hg2O. Okay, so this is about the tailing of mercury. Okay, then this is about the sulfur. Okay, under this allotropy. I told you in previous classes. What is the meaning of allotropy? Simple. The allotropy, nothing but what? The substances, the compounds which are show the different okay, chemical property or physical property. Tell me guys, different physical properties, but same in chemical properties. Different physical property, but maximum same in chemical properties are called allotropy. Similarly, here sulfur also show the some allotropies. What are those? Number one allotropy is here rhombic sulfur. That is also called as what? Alpha sulfur. Rhombic sulfur or alpha sulfur. Okay, it is a most it will show the most stable form in the nature. Okay, and the rhombic sulfur is present in the crown type shape. This is called as crown type. Okay, this is about the structure of the rhombic sulfur, that is alpha sulfur. Here, how many sulfurs are given here? 1, 2, 3, 4, 5, 6, 7, 8. That means what? This is about the S8 structure. S8 structure. It is present in the crown shape. This is about the structure of the rhombic sulfur or what? And also called as alpha sulfur. And also called as the alpha sulfur, like this. Rhombic or alpha sulfur. It is a most stable in the nature. This is about the one type of the allotropy of the sulfur. Then second one is that is monoclinic sulfur. This is also called as beta sulfur. Whereas in rhombic that is called alpha. Whereas in monoclinic that is called beta sulfur. Okay. It is the beta sulfur is containing look like this structure. This is called as beta sulfur. There is also available S8 atoms like 1, 2, 3, 4, 5, 6, 7, 8. That means what? S8 structure. It is nothing but what? Needle-like structure. Needle-like structure. So this is about the monoclinic or beta sulfur. So there is available so many allotropic natures of the sulfur, but among those we have to discuss about the important one. What are those? Alpha sulfur or what? Or rhombic sulfur, beta sulfur or monoclinic sulfur. Okay. So then now we discuss about the sulfur tetrafluoride. So the structure of the sulfur tetrafluoride. Here in sulfur tetrafluoride, sulfur is acting as the central atom. Around the central atom, how many fluorines are given? 1, 2, 3, 4. 4 fluorines are bonded towards central atom of the sulfur. Here in this case, yeah, here to here. Here to here, the bond length in between here, the bond length is what happened? Yeah, this is a bond length that is 164.6 picometers, and then here to here, the distance here to here in between fluorine and sulfur, the bond length is 154.5 pm. Then here to here, the bond, that means for the sulfur to this fluorine, that is a Wedge formula. The bond length is 101.6 degrees. Here to here, the bond length that is 173.1 degrees. So this is about the sulfur tetrafluoride. It is containing which geometry? Here the geometry is nothing but what? Here there is available trigonal bipyramidal geometry. It is involving in the trigonal bipyramidal geometry, and also the hybridization is sp3d hybridization. It is participate in the which hybridization? Very important one. Your competitive purpose like NEET and JEE mains, whatever maybe. So here the geometry is what? The geometry is very simple, trigonal bipyramidal. The hybridization is sp3d hybridization. So this is about the sulfur tetrafluoride. Right, then now we discuss about the sulfur hexafluoride. So that means what? Here the sulfur is acting as a central atom. Around the central atom, 6 fluorine atoms are bonded towards sulfur. 6 fluorine atoms are bonded towards sulfur. So this is about the sulfur hexafluoride. The hybridization is what? It is participate in the sp3d2 hybridization. Whereas in sulfur tetrafluoride, there is participate in the sp3 dehybridization, but in hexafluoride it is participate in the sp3d2 hybridization. sp3d2 hybridization, as well as the shape of this this compound is octahedral shape. It is participate in the octahedral shape. So this is about the sulfur hexafluoride, right? Then here some more. The structure of, that is resonance structure of the sulfur trioxide. Resonance structure of the sulfur trioxide. Here there is available always the sulfur trioxide is participate in the hybridization is sp2 hybridization. It is participate in the sp2 hybridization. That means what? One s orbital is interact with the overlap with the this p orbital and this p orbital. That means what? One s orbital, two p orbitals. That's why it is participate in the sp2 hybridization. What about remaining? This is electrons are responsible for the formation of the pi bond. This electron also responsible for the formation of the another pi bond. This electron also responsible for the formation of the another pi bonds. Here how many pi bonds are available? 1, 2, 3. 3 pi bonds are available. Look like here. Here 1 pi bond. Here 1 pi bond. Here 1 pi bond. Around this sulfur there is available 3 pi bonds. Okay, like 1, 2, 3. These 3 electrons are responsible for the formation of the 3 pi bonds in the sulfur trioxide. Okay, this is about the resonance structures of the sulfur trioxides. Right, then here now let's we discuss about the sulfur dioxide. Sulfur dioxide, the formula is what? SO2. SO2 is called as what? Sulfur dioxide. Here the preparation methods. When Na2SO3 is react with sulfuric acid and gives rise to form Na2SO4 plus H2O as well as our desired product, that is sulfur dioxide. It is a first method for preparation of the sulfur dioxide. And then second method is FeS2, which is react with the oxygen molecule, is gives rise to form Fe2O3 as well as our desired product, that is sulfur dioxide. It is also one of the second method for to preparation of the sulfur dioxide. Right, then right, structure of sulfur dioxide. Here around the, actually here the central atom is what? Sulfur. Around the sulfur there is available 2 oxygen atoms like this. This is 1 oxygen atom. This is 1 oxygen atom. Actually here in this case the valency of sulfur, how much here? We know already. It is belonging to 60 group elements. That's why the valency of the sulfur also 6 electrons. That means what? Here around the sulfur there is available 6 electrons. We have to indicate here. Yeah, here 1 electron, here 1 electron, 1, 2, 3, 4, 5, 6. It is a one lone pair. Okay, around the sulfur, I told you just now, there is available to occupy 6 electrons. So again, once again repeat 1, 2, and then 3. What happened? Okay, here 1, 2, 3, 4, 5. Around the sulfur, there is available 6 valency electrons. Okay, in between this oxygen and this oxygen, the bond length is 119 degrees. In between here, the bond length in between the lone pair 2, that is oxygen, there is a bond length is 1.431 angstroms. Okay, so this is about the brief discussion about the sulfur dioxide. Now, properties of sulfur dioxide. Okay, it is very, very important one. Sometimes it is also asked for very short answer type questions. Right. The first property of sulfur dioxide is it is colorless gas. Already you know already. Sulfur dioxide always present in the which state? It is present in the gaseous state in the nature. Okay, it is a gaseous state in the nature. That's why it is a colorless gas with a rotten egg odor, rotten egg smell. Okay, it is highly soluble in water. Okay, the sulfur dioxide is highly soluble in the water. Then it is liquefies easily. That means what? It is formed as a water so easily. There is no other forces, right? Then third point, that is SO2 dissolve in water to form sulfurous acid, due to which it is possess an acidic character. Okay, sulfur dioxide is dissolved in water to form sulfurous acid due to process of acidic character. That means what? Sulfur dioxide is formed easily sulfuric acid due to presence of the acidic character. Due to presence of the acidic character. Already I mentioned here. Okay. In this case, here, yeah, water is react with sulfur dioxide is gives rise to form H2SO3. That is sulfurous, not ec. Okay, sulfurous acid. Then next point, it does not support combustion, nor it is combustible. It cannot support the combustion type reactions. Okay. Then here, SO2 is strong oxidizing agent. It is also acting as the strong oxidizing agent. Like here, H2S is reacted with SO2 is gives rise to form sulfur plus water molecules. That means what? It is indicating as the sulfur dioxide is acting as the strong oxidizing agent. Okay. Here, the rest of the sulfur H2 is there. The rest of the sulfur, there is no H2. That means what? It is acting as the oxidizing agent. Okay, this is about the oxidizing property of the sulfur dioxide. Then next point, it is also act as the reducing agent. That means what? The sulfur dioxide is acting as the amphoteric nature. That means what? Sometimes it is acting as the oxidizing agent, sometimes it is acting as the reducing agent also. For example, here sulfur dioxide is reacted with water molecule is gives rise to form sulfuric acid plus one hydrogen. That means what? Here eliminate the hydrogen. This is also indicating as what? The sulfur dioxide is acting as the good reducing agent in the nature. One more important thing, that is SO2 is used as anti-chlor. What is the meaning of anti-chlor? To remove the excess of chlorine on the cloth. So that's why sulfur dioxide is used as the anti-chlor. Anti-chlor, it is important point. It is very, very important point. So note down this one. Okay. So this is about the properties of the sulfur dioxide. Right. Then uses of sulfur dioxide. The first uses in the it is used as the in the food industries. It is used as in food industries as a food preservative. That means what? For storage purpose, we have to add the sulfur dioxide. Okay, most of the restaurants are use the sulfur dioxide. Why? Because those are in these cases we have to use the sulfur dioxide as the preservators to preserve the food particles in the restaurants, whatever maybe in 5-star hotels also. So this is about the sulfur dioxide. Then it acts as a bleaching agent to remove the excess chlorine and as a disinfectant. That means what? Just I told you, bleaching means what? It will act as a bleaching agent to remove the excess of the chlorine. That means what? To remove the excess of the dirt particle which are present on the cloths. Okay. So then in cold storage plant, it is act as a refrigerant. That means it is also acting as a refrigerant, good refrigerant in the nature. Then it is used as reagent and a solvent in the laboratory. That means what is the meaning of reagent here? Reagent is a substance or compound which are added to the reactant to complete the reaction. to run the reaction. That is a property of the reagent. That's why the sulfur dioxide also acting as the good reagent in the our laboratory purpose. Okay. So we have to generally have to observe in our laboratory purpose. Okay. Then here last one, that is safely measures have to taken against sulfur dioxide, as inhaling this gas causes serious health problems such as premature death and respiratory problems. By using every day, by using every time, the sulfur dioxide also causes to form the some respiratory problems. So that's why this is also sometimes to provide the to causes to form the respiratory disease. Okay. So this is about the uses of the sulfur dioxide. Okay, my dear students, right? Then here, oxo acids of sulfur. Here, first one is sulfurous acid. Sulfurous acid. The formula is H2SO3. Here, the central atom is what? Sulfur. Around central atom, how many HO groups are there? One, then two. Here, just only one oxygen. That means what? Around sulfur, how many hydrogens are given here? One, two hydrogens. One, two, two hydrogens. Then how many oxygens are given here? Three oxygens. One, two, three. Three oxygens are given here. Then and next, okay, two hydrogens and three oxygens. Right. Before that, you know already the valency of the sulfur is how much here? 6. Here it is satisfied the 6. How it is satisfied? 6 electrons are there here. 1, 2, 3, 4, 5, 6. Okay, once again repeat you. 1, 2, 3, 4, 5, 6. That's why here sulfur is acting as a central atom. Okay, always one thing is there, always in between sulfur and oxygen there is available one double bond, and also always hydrogens are combined with the oxygens. So that's why there is available two HO groups and one S double bond O groups and one lone pair of electrons which are present on the sulfur. So this is about the sulfurous acid. As means what? Less number of oxidation number. That's why which is representing as the H2SO3. It means what? More number of oxidation state of the sulfur. So this is about the sulfurous acid. Then we are entering into second one, that is sulfuric acid. It means what? The sulfur which is show the more oxidation number when compared with the sulfurous acid. Here, in this case, here also there is available. How many oxygens are given here? 4 oxygens. Here 1, 2. How many hydrogens are given here? 2 hydrogens. That's why 1, 2. Okay. So 2 always, just I told you, always the hydrogen atoms are combined with the oxygen molecules, oxygen atoms. So that's why 2 hydrogens are combined with the 2 oxygen molecules. Like here 1 HO, here 1 HO, remaining sulfur double bond O, here remaining sulfur double bond O. Here also the sulfur is containing 6 valence electrons. Look like 1, 2, 3, 4, 5, 6. That means what? It is also satisfy their valency electrons. So this is about the sulfuric acid. Right? Then that is third one. Peroxy disulfuric acid. Peroxo disulfuric acid. The formula is H2S2O8. How many heads are given here? Yeah, 2 hydrogens. 1 OH, 1 OH. How many oxygens are given here? 8 oxygens. Look like here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 oxygens also satisfied here. But why this is called as peroxy? Due to presence of these 2 oxygen. This is called as what? Peroxy bond. Due to presence of the peroxy bond, this is also called as peroxy disulfuric acid. But in disulfuric acid, there is available 2 sulfur atoms. Look like 2 sulfur atoms. It is very, very important on your competitive level. That's why you have to more focus on this type of structures. Okay. Then that is fourth one, pyrosulfuric acid. That is also called as what? Oleum. It is a peroxy, that is peroxo, it is a pyro. So here the structure is what? The formula is H2S2O7. Here H2S2O8 is a peroxo, Here H2S2O7 is a volume. Okay, volume. In the structure, there is available. How many sulfurs are given here? Two. One, two. How many oxygens are given here? Actually, seven oxygens. One, two, three, four, five, six, seven. Okay, in between two sulfur, there is available two oxygen. Whereas here, in between two sulfurs, there is available two oxygen. That means what? It is indicating as the peroxy bond. There is no two oxygen. That's why it is indicating as the pyrooxygens. Pyrooxygens. Okay, so this is about the structure of the oxo acids of sulfur, right? Then manufacturing of sulfuric acid. It is a very, very important one, which is asked for 4 marks purpose or sometimes 8 mark purpose also. That's why the most of students, not only most of students, all of you more concentrate on this question. That is manufacturing of sulfuric acid, which is also called as contact process, which is also called as contact process. In this contact process, you have to prepare the sulfuric acid, that is H2SO4. In this process, first the sulfur is reacted with the oxygen molecule, is gives rise to form sulfur dioxide. Gives rise to form sulfur dioxide. Okay, look like here. Then second step, after formation of the sulfur dioxide, here after formation of the sulfur dioxide here, again the sulfur dioxide is reacted with X amount of the oxygen molecule, is gives rise to form sulfur trioxide. After formation of the sulfur trioxide, then here the sulfur trioxide is reacted with H2SO4, that is sulfuric acid, to form H2S2O7, which is also called as volume. Which is also called as volume. Or after this, again the sulfur trioxide is reacted with water molecules to gives rise to form sulfuric acid. Sulfuric acid. Okay, so that means what? After formation of your volume, look like here. After formation of the volume, which is reacted with the water molecule to provide sulfuric acid. That means what? After formation of the volume, which is participate in the reaction by using water molecule to provide the purified sulfuric acid. Okay, so this is about the preparation of sulfuric acid. In we have to representing as the diagrammatically. This is a diagram which is relevant towards preparation of the sulfuric acid. This process also called as contact process. Here we have to insert the here sulfur. Here air is you have to insert this tube. That chamber also called as sulfur burnal. Okay, the chamber is called about dust precipitator. The chamber is called about washing cooling tower. Okay, this chamber is called about drying tower. Okay, so in this case, here when there is a sulfur is there, the sulfur is reacted with oxygen which are present from the air. Then the sulfur is reacted with sulfur is reacted with oxygen molecule to form sulfur dioxide. To again in this case, the sulfur dioxide is again reacted with the oxygen molecule, which is passed through the what? This tower, then which is also passed through like this here to here. Here there is available concentration H2SO4 spray, and any waste acid is there. Those waste acid is go outside through this tube, and after to formation of the sulfur, here in this case again the sulfur dioxide as well as oxygen molecules are passed through this tube, and then here there is available one operator. What are those name is what? Arsenic purifier. Okay, in this arsenic purifier, the substances are purified to each other by using arsenic purifier operator. From this, the sulfur dioxide as well as oxygen molecules are transferred to here. Here it is nothing but about preheater. In preheater, the use of the preheater means what? It will provide the heat to participate in the reaction. Those all molecules are passed through this chamber. The chamber is containing V2O5. Here V2O5 nothing but about catalyst V2O5, or here you have to use the platinum catalyst also. But the most of the cases V2O5 is acting as a good catalyst to complete the preparation of the sulfuric acid. When the sulfur dioxide as well as oxygen molecules are passed through here through the catalyst chamber. Then the sulfur dioxide plus oxygen is converting as the sulfur trioxide here. It is very, very important one. Sulfur trioxide. Though sulfur trioxide is okay, sulfur trioxide is passed to this chamber. Here there is available concentration H2SO4 spray. That means what? Here by passing sulfur trioxide through the concentration H2SO4 here to form as the volume. This is indicating as the volume. That is what? H2S2O7. Here again, volume is participate in the reaction. Look like here, volume is participate in the reaction by using water molecule to provide the purified sulfuric acid. So in this case, the some optimum conditions are available. What are those optimum conditions? Number one optimum condition is here you have to use the 700 degree centigrade temperature. Here you have to use the 700 degree centigrade temperature and 1.5 to 1.7 atmospheric pressure. 1.5 to 1.7 atmospheric pressure. And then, okay, here you have to use the catalyst is V2O5, that is vanadium pentoxide over platinum catalyst. These three are optimum conditions to complete the contact process, okay, to preparation of the sulfuric acid. Okay, it is very, very important question, dear students. That's why you have to more concentrate on the preparation of the sulfuric acid in the contact process, right? Then here properties of sulfuric acid. Here, the physical properties of sulfuric acid. The first property is pure sulfuric acid is an colorless, oily liquid, okay, without any odor. That means what? Without a smell. Actually, the sulfuric acid is acting as a colorless, oily liquid, which are already we have to observe in our laboratory. Okay. Then second point, the specific gravity is 1.834 at 18 degrees centigrade. Third point, that is it freezes at 10.5 degree centigrade. That means what? It will solidified at by using 10.5 degree centigrade. And then fourth point, that is it is boiling point is 333 degree centigrade. Okay, this is about the fourth point. Then the fifth point, it is dissolved in water, liberating a lot of heat, which raises the temperature of mixture up at 120 degrees centigrade, comma, H2SO4 should always be poured in water in a thin stream to avoid any accident. In generally, this process is we have to observe in our labs. In generally, the chemicals are added into water molecule, but it is quite opposite. By using of the H2SO4, okay, by using of H2SO4, you have to add the H2SO4. You have to add the H2SO4 into water molecule, okay, into water molecule. Generally, what do you mean this one? Can dissolve in water, liberating of lot of heat, which rises the temperature of the mixture up to 120 degrees centigrade. H2SO4 should be always poured in water molecule. That means what? Always H2SO4 is added to the water molecule. In this process, there is erases the lot of heat fumes, So that's why by doing this process, you have to use some operators. Okay, some you have to do this safely. Without safe, it is caused to form the any special accidents. To it will create the injury to our body. That's why by addition of the H2SO4 into water molecule, you have to be alert by addition of the H2SO4 into water molecule addition process, right? So then uses of sulfuric acid. Here, very, very important one. Yeah, generally, the first uses is used to prepare many other acids like hydrochloric acid and nitric acid. That means what? To prepare hydrochloric acid or nitric acid, we have to use the sulfuric acid also. Okay. Then sulfur-emitting agent used in manufacturing of paper, dyes and drugs. That means what? Sulfuric acid also used to prepare the papers as well as dyes. Dyes means what? Colors. Dyes and drugs. Okay. Then manufacturing of modern synthetic detergents, the alkyl benzene sulfonates, that is means what? Biodegradable. To prepare the some synthetic artificial detergents for our alkyl benzene sulfonates, we have to use the sulfuric acid also, which are useful for biodegradable in the nature. Biodegradable in the nature, right? Then electrolyte in lead acid car batteries. That means what? Sulfuric acid also electrolyte, acting as electrolyte in lead acid car batteries. Generally, how to observe the sulfuric acid in lead acid car batteries. Then last one, that is used in petroleum refining process. That means what? Here, to refine the petroleum, to purify the petroleum, we have to use the sulfuric acid also. So this is about the main uses of the sulfuric acid. Okay. So up to this, this chapter is ended. In the chapter, that is especially from 16th group for our 60th group elements, which are important one, my dear students. The first one is the preparation of ozone and the chemical properties of ozone. That is important question from the 16th group elements. Okay, once again repeat you. Preparation of ozone, the chemical properties of the ozone, that is important one. And second one is the preparation of the sulfuric acid by contact process, and there's some chemical properties. So these two questions are play the important role to get the more marks from the P block elements. Okay, and some more 2 marks questions also there. What are those 2 marks questions? You know, the electronic configuration of 16 group elements, and also sulfur dioxide uses. So these type questions are very very important one for very short answer type questions. Up to this, I have to complete my 16th group chapter. Okay. Thanks. Really, I say the thanks for our secretary sir as well as our coordinator madam. Thank you. Thank you very much. Up to this, I will close this session. Thank you. Thank you very much. Okay, sir. Can I close, sir?
Javed sir, please close the session, sir.
Okay. Okay. But thank you. But thank you very much, madam. Okay.
Javed sir? You only end the session, sir. Ramesh sir, end the session, sir. Hello, Javed sir.